In this video, we're gonna build production-grade multi-container application using Docker Stack and Docker Swarm. For those who don't know what Docker Swarm is, I will explain shortly. I'm pretty sure that everyone who watched this video heard about Kubernetes, which is buzzword nowadays. Kubernetes is a great tool, but it is more complex and not every company needs to use it. Docker Swarm is similar to Kubernetes, but it is more simpler. It is Docker built-in orchestration solution that allows you to create and manage a cluster of Docker hosts as a single virtual system. Docker Stack is a higher level deployment tool that works with Docker Swarm to deploy complete multi-service applications. Today we will create a simple task management application with Node.js and PostgreSQL and deploy it Docker Swarm cluster. So what are we building? Let me show you our architecture diagram. We have 5 node Docker Swarm cluster, 3 manager nodes, and 2 worker nodes. Our application has 2 main components, a Node.js application for managing tasks. We will run 4 replicas of this for high availability. 2 replica will be deployed to worker node 1 and another 2 replica will be deployed to worker node 2. Then we have PostgreSQL database for storing our task with persistent volume. It means that even if the containers are restarted, the data will be kept in persistent volume. Both components will run on worker nodes and communicate through an overlaid network, which allows containers on different physical hosts to communicate as they were on the same network. I hope all clear, and now it is time to build the application. You can find the source code in the description if you want to follow along. The only prerequisite is to have 5 Linux nodes with Docker installed on them. We can easily launch these Linux nodes on any cloud provider like AWS, Google, or in your own local machine. I'm using Multipass, which allows to create Ubuntu nodes. Multipass is a great solution and it's available for Windows, macOS, and Linux. If you decide to use Multipass after installation then you can run these commands to launch your Ubuntu instances and then install Docker on them. And if you want to log into those Ubuntu instances, then you can use Multipass, Shell, and Ubuntu instance name. I have already set up 5 Ubuntu nodes. So I have manager 1, manager 2, manager 3, worker node 1, and worker node 2. Now I'm gonna create Swarm cluster. So first let's check the Docker. So we're using Docker version 28.0.4. Now I'm gonna initialize Docker Swarm cluster. It is initialized. Now we are gonna create our token for managers. So I'm gonna use Docker Swarm joint token manager. Something went wrong. I guess it should be joined, not joined. So I'm gonna copy this token and I'm gonna place it in manager 2. This node joined to Swarm as a manager. Then we're gonna run it in manager 3. And if we check Docker node ls, we're gonna see that right now we have 3 managers. And the first manager, the first node is our leader and the others are followers. Then we have to generate our token for worker. So I'm gonna use Docker Swarm joint token worker. Sorry, it should be Swarm. Now I'm gonna copy this command. I'm gonna place it worker nodes. This worker node joins Swarm. Then I'm gonna run it in worker node 2 as well. And then let's check. We can also check in manager 3, it doesn't matter. So I'm gonna use Docker node ls. Okay, this is big. Let's use small. Docker node ls. So we have 3 managers and then we have 2 worker nodes. And they're all active. Now let's look at our application code. We have simple Node.js Express app that provides a web interface for managing tasks. The application displays a task list and allows users to add new tasks. You don't need to know much about application code, as our purpose is to see how to containerize and deploy this application. So let's check our Dockerfile. In this Dockerfile, we are using this node 18 alpine page image. Then we are creating app directory. It will be user source app directory. Then we are installing all the dependencies, which is in this file package.json. We're gonna install these dependencies. Then we're gonna run npm install with production flag. It means that we're gonna install only production dependencies, excluding development packages to keep the image smaller. Then we're gonna copy everything in this line and we're gonna expose port 3000, which means that the application listens on port 3000. Then we are having some health check. So this health check is gonna run for every 30 seconds. It's gonna time out after 3 seconds. And the start period is 10 seconds. It means that it allows 10 seconds before starting checks for application startup, I mean. Then we have retries equals to 3. So it will retry 3 times before marking unhealthy. And this is our health endpoint /health. So it's gonna check that if this health point returns successful response or not. And the last command is npm start, which means that we're gonna start the application. So I'm gonna open my terminal. I'm gonna build this image. So docker build. We're gonna tag it Eshkin task manager. It's gonna be version 1. Eshkin is my profile name in Docker Hub. And this is gonna be our container and with tag 1. So let's build it. The build failed. Let me just close this tab. It says that this Dockerfile is not found. So let's do ls. Yes, we have one more directory. I'm gonna go to version 1. And if we do lsl, now Dockerfile is here. I'm gonna run this command one more time. And now it is successful. So we basically created our first image. Now I'm gonna push it into like Docker Hub. It's gonna be version 1. For some reason it just timed out. So I'm gonna run it one more time. It can happen. Okay, now it is successful. By the way, this is public image, which means that everyone can pull it. We're gonna use this image in our Docker stack file. So let's see this file. If we go to Docker stack and in the services, you see that in the image section, we're using the same image. I'm gonna explain this stack file. Basically, it creates secure communication layer using this encrypted overlay network called Task Manager Overlay Network. It allows services to communicate across multiple Docker hosts. And then we are creating Docker volume called PG data, which will be used for database. Then we have services section. Here we are using the image that we just pushed to Docker Hub. Then we have replicas for. It means that for replicas running simultaneously for high availability and low distribution. Then in the update config, we have parallelism. It is 2. It means that it's gonna update 2 containers at a time. And then it's gonna wait for 10 seconds between updates. And if the update fails, then it's gonna roll back to previous version. Restart policy, it's on failure. It means that it's gonna restart the application if it is failed. Then it's gonna wait 5 seconds for like before attempting another restart. And the maximum attempt is 3 restarts. And the window is 120 seconds. It means that it's gonna consider a service healthy if it runs for 120 seconds. Then placement constraint is worker, which means that this application will be deployed to only worker node. So for manager nodes, we're gonna use manager nodes just for managing our Docker Swarm. Then we have some environment variables for our Postgres database, and we're exposing the port 3000. So basically container port is 3000, and we're mapping that container port to our local machine port, which is 3002. For the application service, we're gonna use this network that we created before, and our application is like dependent on database. If database is not up, then our application service will not be deployed. Then we have health check in this health endpoint. So it allows 10 seconds for each health check to complete. So timeout is 10 seconds. And we're gonna like send request to health endpoint for every 30 seconds. And it's gonna retry 3 times before marking unhealthy. And it's gonna give the application 40 seconds to initialize before starting health checks. Then we have DB service. We are using official Postgres 15 alpha image. In the deployment section, we can see that it is constrained to worker node, which means that database will also be deployed to worker node. There is such policy on failure. It's gonna restart if it is failed. Then we have some environment variables. And for the volume, we're gonna use this PG data volume that we have created before. And it's gonna be mapped to varly PostgreSQL data on the container. And as a network, we're using the same overlay network. We have also health check for this database. We're gonna use PostgreSQL native PG is ready command to verify database availability, and it's gonna check for every 10 seconds, and it's gonna allow 5 seconds for each check to complete, and it's gonna retry 5 times before marking the service unhealthy. So what we're gonna do is we're gonna go to our Docker Swarm. I'm gonna copy my repository. This is public repository. You can clone it as well. And I'm gonna go to YouTube directory. Here we're gonna go to version 1. Sorry, first we have to go to task manager, then version 1. And here we have Dockerfile, app.js, docker stack.yaml, and package.json. Basically all the files that we have seen here. And we are gonna use this docker stack YAML file. So I'm gonna say docker stack. We're gonna use deploy this file docker stack.yaml, and I'm gonna call our stack as task manager. Let's deploy it. So it says that creating network, creating service, and another service. So let's check the network, docker network ls. So yes, our network is called task manager overlay network, and it's just added this task manager stack name before this name. So it is created. We should also have docker volume. So let's do docker volume ls. There is some volume, but this is not our volume. So what we can do is first let's check the services, docker service ls. So here you can see that we have 2 services called task manager application and task manager db. Task manager has 4 replicas and they are all successful, and task manager db has 1 replica which is successful as well. Since our docker stack file, if we go to the db, we have added this volume in the db service. That's why we have to find out this replica, db replica, where it runs basically in which node. So what I'm gonna do is I'm gonna use docker service ps task manager db. Don't pay attention to this rejected. It was before. The current one is this one, task manager db.1, and it's running and it is deployed to worker node 2. So I'm gonna go to worker node 2, and here I'm gonna run docker volume ls. Yes, now you can see that pg data is created here. So we can also check another service. So we have 2 services. We have already looked at this task manager DB. I'm going to use Docker service, PC, task manager app. So in task manager app service, we have 4 replicas. And as you see that 2 replica will be, it is deployed to worker node 2 and another 2 replicas deployed to worker node 1. So for now, everything looks healthy. Now let's access to our application. We can reach our application through any node in Swarm cluster on port 3000. So right now we're in the manager 1 node. So I'm gonna go to manager 3, for example. I'm gonna check the IP. So IP here is 192.168.65.4. I'm gonna copy this IP, and in my browser I'm gonna paste this IP, then port 3000 HTTP. Yes, our application is ready and it is running. So right now we don't have any task. So what we can do is we can create 2 test tasks. So let's say test, it's added, and test 2. So we can easily add our task here. And now for the exciting part, I'm gonna demonstrate rolling updates with 0 downtime. We will update our application to version 2, which changes the theme, the background color from blue to green. So I have already changed it. If we go to our version 2 in app.js, as you can see that right now it is green. This hex code corresponds to green color. So actually here it should be version 2 as well. I'm gonna save it. So anyway, if we go to our repository, currently we are in version 1. So what we can do, we can go to version 2. And in this version, we have the same file. Basically, only change stuff is this color, the version, and also in dockerstack.yaml in the image section. Now we are using version 2. But first we have to push this version 2 image. So I'm gonna go to version 2 here. And here I'm gonna build this image. I'm gonna call it version 2. The image is built and we're gonna use docker push version 2. Image is successfully pushed. And if we go to this terminal here, if we analyze dockerstack.yaml, so as you can see that it is version 2. Now I'm gonna run docker stack deploy dockerstack.yaml and our stack name. Let's press enter. By the way, it is without downtime, because if you remember in our stack.yaml file, we have mentioned that parallelism is 2. It means that we have 4 replicas, but when we do update, first it's gonna update 2 containers, and then after that it's gonna update another 2 containers. So basically there will be no downtime. Anyway, let's check our application. Right now it is blue, but if we refresh it, so it changed to green color. It means that our application has been updated with 0 downtime. So that's it. Thanks for watching. If you have any questions, drop some in the comments below.